Good afternoon to the last session today. That is loud. Today we have this afternoon we have the honor of speaking to Alex Oliva from the Free Software Foundation of Latin America, and he'll be sharing escaping the surveillance black hole with free mobile computer. No, that's the next one. Okay, sorry. That's a sneak preview for Tuesday. Today's talk is Who's Afraid of Spectre and Meltdown. We look forward to listening to you, Alex.
Oh, oops. Hello. Oh, that's better now. I can hear myself. That will work better. So good afternoon, everyone. Thanks for being here. Thanks for having me here. I'm very pleased. It's my first DebConf, and I'm so excited. What's better to have a DebConf in your hometown? And it's awesome. Thanks for the offer for the laptop. And to all the nice video folks who made it work. Awesome job, guys. I'm going to speak about these architectural computer problems that are getting a lot of people worried. And, well, I'm not, so I'm going to tell you why. Are you familiar with Grandma Betty, 33? She's a grandma who passed away, but her grandson posted pictures while she was sick with cancer, I think. I've never met her, but I thought she was so nice and happy and enjoyable that I figured I would assign to her the knowledge that I assign to pretty much every grandma in the world. Like the kind of advice that I expect we might get from her is that prevention is better than cure. I mean, we all have heard that from our grandmas, right? We don't always live by this, but we probably should. Grandma, when you're on your way out, will probably tell you to take a coat because it might get cold, or well, things might get hot, so better have protection. It's very modern grandma, but grandma might also tell you not to let big bad wolf in, because it's usually hard to control big bad wolf once you open the door to him. Grandma will probably advise you to not take candy from strangers, because you don't really know what's in there, right? It could be dangerous. It's very useful wisdom. When I was young, we were taught not to run programs from strangers. Like, there was no such thing as the internet back then. Well, there was, but I didn't have access to it. But the point is, there were the equivalent of websites with large repositories of software. There were often proprietary software, and we were told that it was usually not a good idea to download and run those programs. Now, this has changed over time. Now people are taught to actually run programs from any website that they visit. And these programs take various forms, such as JavaScript or Java or Flash or I don't know what else. WebAssembly, yes, thank you. So all this sort of programs that you don't really know what they're about to do in your computer. And you're taught to just, oh, go ahead with it, don't worry. Grandma would disagree. But in truth, it used to be a lot easier to tell data from programs. There was a time when you had like text files, and then you had data spreadsheets and stuff like that. And if you wanted to display them or you wanted to modify them, you used a program, and those are separate. And then someday, people had this brilliant idea of combining them. Suddenly, you were running a program that could open a spreadsheet, and there were programs inside the spreadsheet, and they would run as you opened them. And soon enough, people figure out that they could be used to spread viruses, computer viruses, of course. The same thing, or a similar thing, is going on with JavaScript. Now, you open a website, and your computer will run a lot of software from this website. And although I don't really know about viruses that use this sort of technique to spread, I know that they can do a lot of different kinds of damages, like gathering information about you, as Pedro said a couple of hours ago. But also they can collect information that is in your browser and they shouldn't even have access to. And this is mostly what I'm going to talk about today. The problem really has to do with the automatic execution of software. It is not unlike taking candy from strangers and processing the candy with your food processor built in. You don't really know what's in there. So there could be malware. There could be trackers. There could be crypto coin miners. There could be programs designed to stop you from doing things that you might want to do, such as saving the web page, viewing the source code of the web page, or even saving a copy of a video that you might want to watch. There are programs that implement DRM in browsers these days, and some browsers are written to download and install and run these programs automatically against your will at times. So I really don't like that. I find that really dangerous. And it's disturbing to me that it kind of defies common sense that I was taught when I was young. And I'm kind of happy to see that some governments are kind of, not quite seeing the light. Like some governments are banning antivirus software because they suspect that the antivirus software is controlled by a different government that could use it to spy on them. It's a legitimate fear. I don't have any evidence that this is actually happening. I mean, that there is spying going on through antivirus software. But there could be. If the software is not free software, if you cannot look at the source code and see what it's actually doing, then it might as well be regarded as spy software. Most of the proprietary software that exists today is either malware or potential malware. We don't know. We usually cannot tell. You're probably familiar with the banning of mobile phones and now all 5G equipment from a Chinese company by the US government. You might have been familiar with the attack to nuclear facilities in Iran, allegedly by the US. I don't know a lot of this, but it's the sort of thing that it's the sort of risk that you put yourself into when you run software that you cannot verify, that you cannot trust. You don't know what's going on in there. So what I want to bring to mind is the issue of sovereignty over technology. and jurisdiction over technology. Even if a government could tell a company that renders services to it, computing services, not having access to the source code to make sure that its service is actually being rendered properly and that something else is not going on is very important. And some governments are beginning to pay attention to these issues. This is especially important when it comes to armed forces and to elections. If you want a democracy, you certainly want to know what's going on in the voting machines. Although I should say it's not enough to ensure that you have a good election. You need a lot more than just machines running entirely free software. Now, although, as I said, governments are kind of seeing the light and trying to protect their own computing, I'm not seeing any government actually caring about security and safety of their citizens when it comes to computing. It's like, well, use whatever you want. We're not even going to give you guidance as to what is trustworthy software and what is not. So we're left on our own. And unfortunately, a lot of people decide to use non-free software, which to me which reminds me, puts myself in the position of the alienist character in the Brazilian writer's story. It was a doctor who found that everyone was kind of crazy in a way, and started locking people in a hospital for treatment. And suddenly he realized that, well, it looks like being crazy is normal, and I'm the one who's crazy because I'm not crazy like them, you know. I feel like that at times, but I can't convince myself. I can't talk myself into believing that I'm wrong on this. I think we should only use software that we can trust, that we can know that actually does what we want. And this is particularly important. This became even more important when Spectre and Meltdown came up. So, has anyone never heard of Spectre or Meltdown before? Okay, so some time ago, like a year and a half, some researchers figured out that there were ways to get to information on a computer in ways they were designed not to allow. And I'm going to show you one specific way here, but there are tons of variants of these bugs that were called Spectre and Meltdown that are basically variants of these problems. So you see, if you can read that code, or if you can make any sense of that, it's comparing two variables and then accessing a memory location given by one of the variables, and then taking one bit from the value that was read from memory and accessing another memory location based on whether that bit is 0 or 1. That's what that piece of code is doing, or was supposed to do. Now, the thing is that computers are very fast, and processors are very fast, and memory is comparatively very, very slow. So computers try to do stuff ahead of time if memory doesn't respond as fast as you would like. So say variable n is in memory, and it takes a while to fetch that value from memory. So in order to keep busy, to keep doing useful stuff, the computer will assume, because the last 10,933 times it went through that test, x was actually less than n. It will assume that x is really less than n this time, and go ahead and perform the conditional computation there. So then it tries to, it just so happens that this time x is actually a much larger value, and it shouldn't pass the test. But since it's speculating, it will go ahead and try to access a memory location that is way out of bounds that it shouldn't even have access to. See, the memory is not accessible. You shouldn't be able to get to its value from this program. But since the computer is just speculating, and if it turns out that the assumption that it made is wrong, it will undo most of this stuff. It won't bother to test whether memory is accessible at this point. It will just keep going. Okay, let's access this memory location. Let's take this bit from it. And let's access this other piece of memory from it, based on the value of this bit. And then, oh, well, x is really less than n. So, never mind. Well, we wasted some computation. And it throws that away. The problem now is your program can access the memory location C0 or C1. And one of them will have been fetched to the memory cache, while the other won't, because it was not accessed. So you can tell the value of the bit that it was read from a memory location that you shouldn't have access to. So there is an information leak there. And you can get one bit, and then another bit, and then another bit. And with enough of those, you can obtain a credit card number that was hiding in the memory of the browser. Or you can get a cryptographic key that is, or a crypto wallet number that should be hiding in protected memory. So this researchers have figured out how to bypass the sandboxes within browsers that JavaScript should be contained to. It can get to data from the browser. It can get to data from the userland, from the kernel. It can even get to data from host if your kernel and browser and stuff are running in a virtual machine, despite virtual memory that should protect you from this sort of attack. So this got a lot of people very uncomfortable and worried about the kind of data that would be exposed by just accessing a website and running the JavaScript that's in there. But why should you worry? If you have personal data on your computer, yes, you should probably at least be a little concerned about that. Of course, the answer is not to not have any personal data on your computer. That would be like throwing the baby away with the bathwater. So what is the real solution for this kind of problem? So what we have to realize is that the software that we use, the software that we run on our computer, if it's reliable, or rather, if it's trustworthy, if you can actually believe that it does what it purports to do, that means if it serves you, if it's in your control, that requires it to be free software. And if you actually went through the trouble of auditing the source code, and ideally use a reproducible build system, then you might as well change the program. See, the program serves you. Each of the programs running on your computer serves you if these conditions are met. So you might as well have changed any of the programs to, instead of having to exploit this feature to obtain data from the other program, you could change the other program so as to voluntarily send the program to the party that was interested. See, if all the programs running on your computer are under your control and doing what you wish, there is no problem whatsoever if one program can get data from the other. Now, if these conditions are not met, then the program does not serve you. Why should you use it? It's attending to someone else's interests. Free software is free software that is controlled by the user. It's software that respects users' essential freedoms to run the program for whatever you wish, to study the source code and adapt it if you find that it doesn't do exactly what you wish. And these are essential freedoms that enable you to take care of yourself. But there is so much software, there is so much free software that nobody can audit and verify and adapt all the software that we use day to day. So we need additional freedoms that enable the community to work together. And these are the freedoms to make copies and distribute them to whoever you wish, and to improve the software and distribute the improvements. If you can do all of these, then you can form a community like Debian that cooperates, that collaborates to make great to make and distribute and make available great software, free software, software that serves the users, software that does not control the users, but rather software that is controlled by the users, and therefore software that, as long as the user can trust the people who did the auditing and packaging and verification, is software that is safe to run despite Meltdown and Spectre. So you see, we used to promote free software only on the grounds that it is a human right. You are entitled to control your own computing as much as you're entitled to control or to express your own thoughts. This is a matter of human rights. It's an essential freedom for life in the digital environment. Now we add another layer of importance to software freedom, which is your data security. You need the entire operating system to be free software and to be under your control and audited by people that you trust. You need all the applications that you use to do that as well. You need all the libraries, all the plugins, all the add-ons, however you call them. You need them to be trustworthy. You need all the software that is embedded in data files to be trustworthy. You need all of the drivers, all of the firmware, even the microcode, ideally, should be free software. And if any of these pieces are not free software, I call them fake news. They're not free software. They're not in line with the values of GNU. You better not use them. Oh, then I'll just use a web service as a substitute for the software. Well, that's worse. Because then, besides giving up control over your computing, you voluntarily grant control over your data. So it's worse. You don't even stand a chance of reverse engineering the software and modifying it to do what you wish. So don't do that. Now, people ask me about, well, virtual machines and hiring virtual machines. So is every kind of using third-party computers to do your computing wrong? Or is that something that should be avoided in all cases? It's not so. Let's look at the case. If you have a local computer, well, make sure it doesn't have Intel Me or AMD PSP. Those are backdoors that will run underneath the operating system and enable third parties to control your computer remotely. So if you steer away from that, and that is not a small proposition these days. Let's compare that with having your own computer locally running here or remotely. That's your own computer still, and it's running in someone else's data center. There's nothing wrong with that. Sure, you place a little trust on the data center manager, but that's not, they don't have control over your computing. As long as you use your computer, you should be fine. Now, say you, instead of using your own computer, you hire, you rent, for instance, a computer from the data center manager. That's still fine. You still have access. You still have control over your own computing. If you trust the service provider, that should be fine. Now, what if the service provider is interested in saving costs and they actually have a single machine with multiple tenants? Well, if the service provider maintains each tenant separate from the other so that they cannot look at the other's computing or data, and so that they hardly can tell that they're sharing the same computer, there is no ethical problem there. They're not actually taking over control over your computing. They're not getting your data. They're not controlling your life through your computing. So that's fine. The problem for them, not for you, well, not directly for you, the problem for them is that Spectre and Meltdown brought down the walls that separated one tenant from the other. And now it became much harder to keep them actually separate. So, in a way, it's their problem to solve. If they were serious about computing freedom for themselves, they would actually separate tenants in different computers, physical computers. Of course, there's a lot of costs involved in that. So they're probably not doing that, and so you're probably exposed, not to the past variants of Spectre and Meltdown, but to the future ones that have not been announced yet. Of course, vendors of these kind of services have panicked, and users have worried about the separation of their data, and they might as well worry. Shared computers are an illusion that we like to pretend that we can actually enforce, but in reality, it's been a very long time since we could actually trust that separate threads could not interfere with each other running on the same computer. So there is a real risk there. I prefer to do my computing on my own computers. Now, some people listen to this and think, well, but you're saying that having all the freedoms is enough for the software to be secure? No, I'm not saying that. I'm saying that it's a prerequisite. It's essential, but it's not enough. If you have the 4 freedoms, then you can audit the source code, you can modify the program so that it does what you wish, and can do that in community. But you have to actually make sure that the code does what you wish. Otherwise, you're no safer than without the 4 freedoms. But the fact that the source code is available makes it less likely that people will actually embed undesirable features in them. It doesn't make it impossible, but people will actually try to avoid and prevent that from happening. Otherwise, they'll be granting control over their users to third parties, which most free software developers and distributors do not want to do. Now, we can defend ourselves because we have the 4 freedoms. We can help each other. Say, if someone tried to post a patch to some free software project to introduce a malicious feature, it's usually the case that it will be caught. Not always. There's no guarantee. being alive is a risk. But odds are that it will be caught, especially if it's an attempt to deliberately exploit one of these architectural bugs. Because the exploits are actually quite elaborate. They would like jump out if someone tried to put them in as part of some other feature, I think. I like to trust our code reviewers to catch that on contribution. If not, there are people who occasionally go through various key free software projects to catch problems. So the fact that the attack is actually quite elaborate makes it less likely to be put in deliberately. As for accidental errors, well, there are tons of those. That's why it's so important to have the freedoms to fix them and not depend on the software supplier. But the fact that there are barriers against for instance, the undesirable access to protected memory built into the computers, those are meant those will likely block accidental errors that could be exploited to access memory in undesirable ways. So these barriers remain up. Now, there's still NetSpectre, that is one of the variants of the Spectre bug that can be exploited over the network. Well, yeah, that is one variant that you actually should worry to some extent about. And the defenses that free software offer you for them is that people can audit the source code that could be vulnerable to remote exploitation and fix those, so we can defend ourselves. As opposed to the other variants, they're all, one after the other, have fallen to your having control over your computing. This one is the exception that we actually need action, more action to get rid of. And then there is the worldwide execution lab. That's, I call it that way because it's kind of, we're being executed as opposed to the software. So there are web pages with all sorts of proprietary software. And that we're taught to happily run on our computers. And taught to actually allow it to run and not mind about that. That's very bad practice. Well, grandma would not approve of that. Let's put it this way. So there are various ways you can avoid, you can prevent that from happening on your computer, even though developers are so happy to add JavaScript to their web pages. You can defend yourself from that. We as users should demand developers to offer JavaScript-free variants, or at least a small degradation is okay, but the service should run, the website should run without your letting the big bad wolf in. So what can you do? We can use GNU Libre.js. That's a plugin for Firefox and variants thereof that will verify every piece of JavaScript that is on a web page and will only allow it to run if it carries a free software license. Well, that's good if your goal is to only run free software on your computer. But it's not enough, because there could be free software that does bad things on your computer. So you have to do more than that. You can use Libre.js code auditing features to actually look at the JavaScript that is in there and decide whether or not you want to run it. No script will help you with that because it will block all JavaScript by default. And then you can decide on a per website or per source basis which pieces you want to run. There is Grease Monkey. That's a tool to write user scripts that modify what a web page looks like. So we could use that to selectively enable or disable JavaScript and adapt a web page so that the web page does what you want, so that the software on the web page does what you want. That's one of the essential freedoms of free software, after all. There is, I didn't mention it here, but there is a U-matrix. It was shown by Pedro as well. It's another tool to control what you want to enable to run on your computer. And this is essential, but these tools are hard to use. We need easier tools for users to enable or disable JavaScript or whatever a browser could run from a website, from a random website, to guarantee that we keep the freedoms and to guarantee that we keep the security of our systems. So we need to be able to audit, to adapt, and even to select and replace versions of software that is running as part of a website. We need control, to put control back in the hands of the users. And if the users do not get the control back, it's better be blocked. And then I showed these ideas to a friend of mine. I used to work at Red Hat, and he was very deeply involved with Spectre and Meltdown. And I said, well, your argument doesn't make sense. Because the moment you access a website with JavaScript, everything is lost. I said, exactly. That's what I'm saying. You shouldn't do that. You should block JavaScript unless you can audit it. Just like you shouldn't download any software from any random source and run it before you get a chance to audit it. Now, what can you do if you don't run only free software on your computer? Well, they recommend, the industry recommends you to install a microcode patch that will make your computer much slower, like 30% slower. Even they even try to forbid people from publishing benchmark results after the updates. So you see how big of a hit that was. And you don't know what other undesirable features these updates might bring. So think about that. Think about this possibility of not installing these updates, keeping your computer fast and secure, running only free software that you have audited or that someone you trust has audited for you. Because, you know, even if you keep your machine patched, there are other variants coming up. We know that. Some people already know about them. We know that. They could be exploiting them. We know that. So why place yourself at risk? Why should you run around blindfolded? It's dangerous. You should understand the gravity of the situation. And don't let Big Bad Wolf in. One US president once said that we have nothing to fear but fear itself. So you might as well not fall for these threats and keep your machine free and safe. Thank you very much.
Thank you very much, Alex.
We have like...
We have a few time for questions. There's a mic there, and I can run with it as well.
And if you don't have questions now, I'll be happy to answer them afterwards. I'm around until Tuesday. And don't miss Tuesday at 1:30.
Yes, there's
The other one, escaping the surveillance black hole with free mobile computing. No questions? I hope that. Oh, please.
I guess to be close. Just to pick up on your last slide where the argument was that you shouldn't download the firmware updates. Free FSF has this huge thing about if it's a downloadable firmware update, then it's bad, and we ignore the fact that the code's already running anyway. There's already firmware embedded in CPUs, microcode already exists on it, so the dichotomy of don't download the non-free firmware because that puts you at more risk or puts you at a disadvantage is an unfair one. You mentioned the PSP and the Intel ME. I know that ARM have some embedded firmware stuff going on as well at low underneath OS. Are there any decent processors these days that we can actually trust? I mean, even RISC-V, as I understand it, has some blobby bits in it in the ASIC implementations. So is there any safe CPU to run?
That's an excellent question. Thank you for that. So I see two parts in that. One is the issue of whether the microcode in the CPU is any better than the microcode update that you might load onto it. And the other is there any CPU that does not involve that trade-off? Is that a reasonable summary of your question? Okay. The latter. I'm very hopeful for RISC-V. But I'm hopeful. I don't know enough about hardware to tell you you can trust blindly trust any of the non-free CPUs that are out there. It's really blind trust, right? If you cannot see the specs and if you cannot reproduce the build, then it is blind trust. So I don't have a positive answer to the second part, unfortunately. But I'm hopeful. We're probably getting there very soon. As for the first part, free software is about ethics. It's not about the technical aspects of the risks that are there, but rather about whether it's ethically wrong for someone to deprive someone else of an essential freedom. That is the key argument for free software. Now, when you take a microprocessor that has built-in microcode, that might as well be a hardware circuit. You don't know whether it is a hardware circuit or a program that is loaded on a non-volatile piece of memory, or if it's burned on a permanent piece of memory. You really don't know. The processor is a black box. The fact is that you need, that is one of the components that go into the processor. And as long as you know that as long as you do not attempt to modify it, you might as well take it as a piece of hardware. It's indistinguishable. And in that, there is no convincing ethical argument against one or the other practice. They're both indistinguishable, ethically speaking. You don't agree with that, I understand. The moment you actually modify that, you make that visibly modifiable, then it is evidently an attempt of the vendor to remove your freedom to modify that piece that was made to modify the behavior of the computer. So this is clearly unethical from the free software point of view. Now, whether these are identical or indistinguishable from a technical aspect, I totally agree with you. We're much better off with only with a CPU that did not have built-in secrets. There's no discussion about that. But that is not the ethical issue. The ethical issue is whether it's wrong to deprive the user from controlling software that runs their lives, that runs their computing. And when that piece is indistinguishable from hardware, setting a higher standard for that, just because we know that it's not actually hardware, although it could be, seems odd, so we don't do that. That is why we make this distinction that, well, the one that is there is fine, sort of. It's not ethically bad, but it's just undesirable. Whereas the replacement, the update, well, you should rather not use it. I hope that makes sense to any of you. Thank you so much. We're out of time, understand? So I'll be around. I hope we can talk more about that if you like. Thank you.
Thank you very much, Alex.